This is my talk from 2018 DockerCon. I actually did this talk twice, both at DockerCon US, DockerCon EU, and this is the later one from the end of 2018. And this talk is specific to Swarm and talking about the different layers of technology that you need to address when you're building out a full production-like cluster. You need to have more than just Docker installed with Swarm enabled. You need other third-party tools on top of that. And I go through the different layers of the tech stack, as I call it, and I show off demonstrations of how you would deploy those, what they would look like inside of your stack files, stuff like that. So enjoy.
Great. So thanks for coming to the next track in our IT infrastructure and operations. I'll be your MC, which means I just introduced Bret. So Bret would like me to say that he teaches people Docker on the internet and that he lives on a beach in Virginia. And with that, I'll hand you over to Bret.
Hello. Thanks for being here after lunch. Hopefully, you won't be falling asleep, and we'll keep it going fast. So I've been doing DevOps since before it was DevOps, and I do IT stuff. I'm mostly an operator, but I pretend to be a developer. So I come at it from an ops side, and for the last since Swarm mode. Since classic Swarm, if you're familiar with that thing, before Swarm mode, I've been deploying Swarm in production for companies. So everything I'm going to do today, I'm going to cover lots of little things that are resources and configs and examples and tools. So they'll all be on that URL. I'll put it at the end slide in case you don't write it down or you miss it. And of course, on any of this stuff, you can always reach out to me on Twitter and ask me about the stuff. So this talk is a spawn out of last year's talk. So I don't know if anyone saw my last year's talk at 2017, but it was about how the decisions you need to make for orchestration, even if you didn't orchestrate, but just Docker production in general. And it was more about system level decisions from layers, best practices in Docker files, stuff like that, all of the sort of things to accelerate your project going to production. And so this year came out of that, which was 15 years ago, it was easy. You just put PHP on a server, you put MySQL on that same server, you connected to localhost, and we called it the LAMP stack. And that was kind of the typical deployments for that particular environment. And it was very easy to understand. So in the community, I think that we need to get better pretty quickly, since we're also rushing to orchestration, on more examples of these stacks of tools that can work together and possibly build out your full stack of technologies. So today we're going to do that. And I'm a fan of Swarm, so I'm going to talk about that. And obviously, all this stuff and more is available in Infinity for Kubernetes. So your choices are much harder, I think, there, just because there's so many options out there. And one of the things that I think actually has come out of this week is that we see patterns of people hopping between orchestrators now. So they do Swarm for easy things, and then things that maybe Swarm doesn't support, they do Kubernetes, and they possibly even move stuff out of Kubernetes that's just easy to work, and they can deploy it in Swarm with sort of the easy button of that situation, especially if they're on enterprise and they're able to use both. So that's an interesting theme I keep hearing on this conference. So this is pretty timely, I think. And who knew that Charles Dickens actually wrote about container orchestration 160 years ago? Because he actually talked about how we have this weird dichotomy of we go on the internet and everything is wonderful, unless you're on Reddit or Hacker News. And then you go and you try to do things and they're just not what you expected, or there's way more complexity and decisions you have to make. So ironically, I just thought that was kind of an interesting quote, because I sometimes every day want to bang my head against a keyboard, and that's what I feel like, is that this is the reality we're living through. So clusters are naturally complex, and I like to grow them slowly over time and add the complexity as you grow with your own understanding and complexity of how these things work. So I never recommend first projects being really big, wonderful, IT perfect solutions. I always try to get people to do it really small. Don't let databases be your first thing you do in a container orchestrator. Like, just put that off a little bit so that you can do the learning and evolve. And so we're going to start from the left, work to the right. I call this one Baby Swarm on the left. And we're also going to look at different tools and stacks that go on top of Swarm. And I'm sure I've seen this 1,000 times at Docker marketing brochures or whatever, if those are a thing. But we don't really see this a lot, which is, this is the open source version. And so we need to fill in some of these gaps with third-party tools and techniques to solve this problem if you're focused on a CE stuff. So the majority of my talk today is on CE and open source tools, and then I will fill in the gaps with how EE might be different if you're someone who's interested in the enterprise edition there. So A little bit about me. I'm a nerd, and I love sci-fi. So who has seen The Expanse? Anyone here see The Expanse? Okay, good. We got some fans. This was a fantastic show this year. In fact, I'm a huge sci-fi fan. Since I was 1 year old, I'm sure I was a sci-fi fan. But I've loved it ever since, like Star Wars in 2001, because I'm an old guy, so those were the things I actually saw. And in fact, just this year, we've actually had so many shows and TV movies. I feel like we're in the golden age of sci-fi right now. Like, everything is awesome. Everything is wonderful. The effects are great. There's actually good actors in them now. It's fantastic. So I don't want to have just a boring average talk. Like, why do we do that? Why don't we have some fun? And if we're going to have to be here to learn, we're going to do something today called Dog versus Cat, which is the domain. If you want to check all this stuff out, you can go there. And we're going to do it sort of
Dog versus cat.
Oh. Can you turn up the audio for me? Let me play that again. That wasn't fun.
Dog versus cat.
Not that I'm comparing this to San Francisco, but I did this in San Francisco, and they had big subwoofers, and it was like a dance studio in here. So we're going to do the dog versus cat vote demo. Everyone here has probably seen this 1,000 times, but we're going to take it up a notch and do more things with it. So I'm going to have to put sci-fi sounds into all these slides because there's a button for everything in Keynote, and I'm going to use it. So we're going to do that. And we're going to talk about a bunch of apps. So let's imagine you're a company and you're just starting out with orchestration. You're putting it in, you're doing Swarm because that's sort of the easy button. Let's just get started. Let's do things instead of discussing our infrastructure for 3 months. And we're going to have one website that's just going to run the static website. Nice and simple, easy example. It's one of the typical demos everybody likes to show is just run Nginx, which is like no one ever does that in production, but let's do it anyway. And then we're going to have a more distributed app that's got persistent storage requirements. So we're going to need to make sure the storage is off server on something that's going to outlive the server, and then it moves around for orchestration purposes. And then let's put a blog in there that's a similar setup where it also needs its own persistent storage. So that's going to be your job as the DevOps today to deploy that, right? That's going to be like your 1.0 orchestration project. And then we're going to use stack files because they're awesome. And even before we got all the tools that were announced today, I love them and use them as often as I can, even with Kubernetes, if you can get away with it on enterprise. And we'll hear some more stuff tomorrow, I think, about that as well. And so what are we looking at here? This is Baby Swarm. Yes,
Laugh it up, fuzzball.
So this is Han Solo sysadmin. So who in here is the only DevOps person in their shop? Okay, so like, yeah, the hands keep going up. So like a quarter of you, which is the typical average I get in an audience. And that a lot of people don't talk about those people. Like you go on the internet and it's always assumed that you have a team of people. And that's tough sometimes because it's really hard for you to do all these things. Like you just start stacking up the tools and it's like, how is one person going to know all this stuff? So I like to start out this way and say, let's just keep it simple. Let's do some things that aren't even cool on the internet. Let's just set some parameters, right? We're going to do cloud agnostic because maybe we don't we haven't made a decision around our cloud, or we want multi-cloud because that's all the rage now. We're going to need TLS because we're doing web everything. We need centralized logging and monitoring, health checks. We need stuff like that. But maybe we don't need serverless yet, or self-healing nodes, meaning that we have auto scale of nodes. Like maybe it's okay if a node fails, that everything redundantly fails over, but we can heal the node manually later because we don't automatically do auto scale out of the box. Like those are things you can always add later. You don't necessarily need on day one based on your requirements, of course. So I'm going to use DigitalOcean because for small startups and scrappy teams, this is a great place to be, especially now that they keep adding new functionality. It's sort of like they're taking all the good ideas of AWS and making it easy again. So I like that. And they have block storage, so we can now use volumes off servers and move stuff around. They have load balancers, so I can put that in front of my web servers, and it all just works. So remember that the apps I just mentioned a while ago, those are going to need more stuff to actually really be a lifelike system, right? We're going to need something like a reverse proxy in front of that because we're going to run a bunch of websites all on the same port. So we need a reverse proxy. Today we're going to use Traefik for that. We're also going to need other things to manage this infrastructure. So we're going to first make some security boundaries to make nice overlay networks. I'm going to have one central proxy network. That's a pretty common strategy on Swarm, is to just make one overlay network for all of your incoming web traffic, and that goes through traffic all to those websites. Then we're going to need management tools. So we're going to need Portainer, the web front end, which is a really nice tool. If you've never used that, it's Portainer. Well, we'll get to these later. ELK for logging, and then Prometheus and its tools for monitoring. So we're choosing at this point not to do the cloud stuff. I'm not saying you shouldn't use the cloud stuff, because quite frankly, who wants to run their own monitoring? It's a pain in the butt. But if you can't afford all that, then maybe you do this yourself on free tools. So we also need more stuff on top of that, because we've got multi-node. So we're going to need a load balancer in front of our multi-nodes. Usually you would use like an ELB, some sort of outside object that you don't have access to. And because we get swarm routing mesh out of the box, that means that any node can receive connections and move the packets to where they need to go. After that, we're going to look at this ridiculous amount of tools we got to use here to make all this work. One day long ago, we all just ran one container on a server and it was fine, but then we got hard. So you can see some of the names in there that you maybe aren't familiar with, like Rexray, which is a storage orchestrator by Dell, open source, that acts as a Docker plugin that will make sure that essentially our storage is on the node connected to the container it needs to have, so that Swarm, when it launches containers, has that persistent storage and it moves if the container fails and goes somewhere else. So we have that. We're going to get Let's Encrypt automatically out of the box with Traefik. So essentially we're going to use labels on all of our applications to give them the proper reverse proxy configuration, so we don't have to do any sort of manual labor. We can just start deploying apps and things just work. We've got some GUIs on top that we'll talk about later. And I'm going to use Docker Machine. This is like scary stuff, because you see on the internet everybody says don't use Docker Machine. Well, you know what? If you've got 5 or 10 servers, Docker Machine's totally fine. Like, it's fine. If you're one person, you don't need to share certificates to get to your TLS engine, so just do this. Like, this is maybe you're not a Terraform or Ansible person yet. That's okay. We're just going to do this. I got 3 little scripts. I can show you real quick. There's nothing terribly impressive about them. PowerPoint is awesome, said no one ever. All right, so let's just look at this real quick. These are scripts. For each loop, I'm using Docker Machine. I'm creating, I'm using a token, obviously, to get into DigitalOcean and create instances, and I do that for 3 servers. I could do this exact same thing for 10 servers. I could probably, if I did 10 servers, maybe separate out the workers and the managers, so that managers are small and lean and don't necessarily run containers, and then the workers themselves are big and can run hundreds of containers easily on a 10-node cluster. And then I'm going to enable monitoring. So if you're not aware, Docker has a monitoring endpoint built in for Prometheus that aids in getting metrics out of it, but it's not enabled by default and it runs on a different port. So you just got to update the daemon file to do that. So that's what I'm doing. That's what the daemon file looks like, nice and easy. Let's make that a little bigger. And then this is me just simply creating the swarm. And of course, you've all seen the Swarm demo that's simply showing you how to Docker Swarm init, and then you join from the other nodes, and it's not very exciting because it's so easy. All right, so I'm just running, all I did was I ran those scripts on 3 servers that I created in DigitalOcean, and then I went into DigitalOcean and I added a load balancer. That's really all I've done so far, because I didn't figure you wanted to see me provision servers. And so that's where we're sitting at. So the first thing I want to do is I want to provision storage. So I want to get the Rexray driver, it's a volume driver, into the Docker engine, and sometimes that's not intuitive on how exactly you would do that. One of the traits of Swarm simplicity is that it doesn't have a knob for everything out of the box. At least it doesn't seem like it does. But it turns out that a lot of the built-in things we can do with services, we can use that to do the things we need to do, right? Like maybe there's not a Docker exec for Swarm, so I can't exec into other nodes from a manager, but I can do things like do this. So I can add a simple little, let me zoom out there so we can actually, I can make a simple service that uses something called Swarm exec, which essentially runs Docker against the host Docker from inside a Docker container, and runs a Docker command on the host on every node once in global mode, which means that any new nodes I add will automatically get this driver installed. And you might call it a hack, but it's a very effective way to get the job done. People have been using this for years. This Swarm exec has actually been around for quite some time. And it just it runs Docker in a container and runs it once. So essentially I'm creating a driver there so that all the nodes have access to off-disk storage in DigitalOcean. You would do this exact same thing on AWS or Azure. You would just use a different driver there. So I would do that. I've actually already done that because it was boring and I didn't want to wait 3 minutes for the drivers to install or whatever. So let's do our proxy. So this is the next thing. Before we deploy any apps or even before we have management tools, we're going to need to share those ports. So I need this front-end proxy. So I'm just going to do a Docker stack deploy. And you're going to see a theme here where everything is a stack. And I'm just deploying different stacks for different things, right? So I'm currently connected to node 1 and I actually will see all the services listed here, all the stacks listed here. So I'm not going to run the Docker stack commands because it's me literally cutting and pasting from the slide. So if I did, actually let me do it over here so it's a little bit bigger. So as we build these out, you'll just see that there's a large list here and we're going to go through this list and we'll check them out. So I could go to this website and this is the sort of first proof that this thing actually is living. So dog versus cat, 8080, which Traefik itself, the proxy engine, has its own web interface that exposes to you the different rule sets that it has in place. And when I install this, by default, it would be empty. But now that I've actually deployed apps with labels that it picks up on and says, oh, you want to accept connections for www or for whatever website you have, and I'm going to move it to that container, all the packets, and that just works. So we've done that. Now we go to our infrastructure. So we need we maybe want a management thing on top there. That's actually the third one, Portainer. Maybe we just want a web GUI. We want to give someone else a web GUI because maybe they're not the command line guru that we are. And then we want Prometheus on top of that and ELK. Now what's interesting here is just like you see in the Helm world where there's Helm sort of gives you the ability to find standards and agreed upon sort of best practice deployments. We have the same thing with compose files, and they talk about at the keynote that there's all these compose files. Well, because compose files are essentially stacked files with maybe a few changes on storage and whatnot, that's what I'm using, and I'm using community projects. So in this case, I'm actually using SwarmProm. And again, all these resources will be on the link at the beginning and the end. SwarmProm is actually a really great set of Prometheus, because Prometheus itself is not enough. You need more stuff to monitor, to round out the full monitoring solution. So this is specifically designed for Swarm, and it has a large and growing list of services here that all add to it. So alerts and sending out alerts to your Slack or your email, dashboards, graphs, Grafana, stuff like that. So I have the simple little website, the www. Dog versus cat. So this is the wonderful advanced single page app that I have that displays text. And then on here, let me just go to Prometheus because I don't want to have to type it. So this is the Prometheus dashboard, which allows me to get graph data basic graph data out of the Prometheus database, and it's collecting all the metrics, and I didn't really have to do anything. So one of the neat things about this is that with this SwarmProm, I can actually now, if you didn't know later this year, if you've ever used a stack file before on Docker Swarm, you can now add layers. You can add multiple YAML files to layers. So I used their stack file, and I didn't even change it. I just added my own changes on the end of it. And so I did Docker stack deploy -c, and then another -c with my own YAML, and it overrides their YAML. So it allows me to deploy the one from their Git repo with my preferences on top of that. And I actually have that in the repo, but I think it's only a few lines. Oh, I don't remember what I named it. Okay, anyway, I won't show you. It's like 3 lines, but it's an override file. If you've ever used a compose override file, it's exactly the same thing in stack files. So we can look at the web interface for Portainer, or I'm sorry, for like Kibana. Sorry, that's for ELK. Grafana and alerts for Prometheus. And all these just sort of work out of the box. Of course, the nice thing about this SwarmProm is that it gives me all the graphs out of the bag that allow me to see all my services, all my stacks, all my tasks, and the nodes separately. And so it's designed for Swarm, right? So it doesn't require me to do the basic fundamentals of getting all of that stuff in there. So you might want to check that out. And the same thing is true with ELK. So there's actually an open source project for Docker ELK, and it's not specific to Swarm, but because it is just a compose file in there, it works. It works great. So for a very small infrastructure where you don't need a whole lot of custom settings in your ELK setup and you just want to do some basic centralized logging, this is a great tool that gives me all the whiz-bang stuff that I need for my logging. And it uses the current stuff out of the box for Kibana and Logstash and stuff like that. So it's all wired up. And all I need to then go do is change all of my compose files for my apps to just shoot their logs to this thing. And you can actually see an example of that in a lot of these. Well, right here I have this logging, but I think in my apps, yeah, this is all I would need to do. Is I'm using the Guelph logging driver, which turns my logging into JSON and then shoots it over to ELK. I just add that to my stack files, and I can choose which things go to ELK. Maybe I don't want everything. I don't want maybe I don't want ELK going to ELK and Prometheus going to ELK. Maybe I just want my apps there so I can manage my app logging. And you can maybe use AWS for the other stuff or something. So you can choose per container that you deploy how that works. And then we're going to actually deploy the apps now. So again, just stack the deploys. And in the case of the Ghost, it's very simple. The voting one is a multi-service stack file that you've probably seen if you've ever done the voting demo. And the Ghost one, I'm going to skip ahead a little bit, but the Ghost one's a little interesting because I give you an example. So it's got a database in there. That database is using persistent storage. So if this database needs to move the container, it will reconnect to its database and work. I'm actually using secrets in there to store the database, password, so I can share them across the app. And then I'm doing a very simplistic backup concept, which is I write a shell script that for each loops every hour, does a MySQL dump, and stores that on persistent storage, like you maybe would do a cron job, but it does it every hour, and then it just dates the file, right? Now you probably would want another service in here that also does cleanup, right? Because usually if you're doing manual database backups like this, you would do cleanup on the old ones. So I would have another service that would just either write a script or just run it in line like I did. And you can start to move this stuff to container orchestration without having to solve every problem you've ever had again with some new tool, right? Obviously, if your backups are advanced enough, you might need something else. But like again, we're talking about Han Solo here, so maybe he doesn't need all that. All right, so maintenance tasks. So people talk about like in Swarm, it doesn't even clean up images. Well, it actually does. You just have to make a stack for that. So you can auto prune your servers every day if you'd like to clean up images. And so if you've ever had this happen to you on any Docker server ever in production, they will eventually fill up with image data because the images don't go away. So I run a for each loop every day in Bash that cleans up on every node because I'm doing this in global mode. So it's deploying it on each node and just running this task, logging the event to the logs, and I just make sure that, obviously you got to have monitoring to track your disk usage and all that, but that works. That works great. So you don't technically need some trigger or some special function in the Swarm API or anything to do a prune, right? This is just a standard Docker command. So I'm running it against the host Docker, again, by bind mounting the host socket from in the container. And in a lot of these, you can actually set up the networking so it doesn't even create a separate network. You can actually make it use the bridge network or the none network so that it doesn't have any way to even get out to the internet. And of course, you can do things like read-only. If you need to. So day 2 operations is everything after day 1. So the rest of your life now is just stack deploy. Like obviously you're going to grow servers as you grow this thing, but really it's stack deploy, stack deploy, stack deploy. I really stress with people update configs and health checks are the 2 areas that you're going to spend time on day 2. So you're going to want health checks in every single app you deploy. That is absolutely a requirement of every project I'm on. Minimum is that there's at least a basic health check in everything we deploy, because there's no way to replace a container anything close to zero downtime without some level of health check so that the orchestrator knows when it's ready for connections and how and all that. So I work with people on health checks up front, but update configs, if you didn't know, by default Docker, when you do updates and anything goes wrong, it pauses. I don't like that in production. I want rollback. I want anything happens bad, I want to roll back immediately in a production environment. So I always change in every stack file for it to roll back. And then maybe in dev and test production or dev and test systems, you would do a pause so that you can play around with it, figure out what was broken before you do stuff. And then test your limits and reservations. So on day 1, maybe you don't have limits and reservations. Maybe you do set at least some limits on your databases, but if you run databases in your cluster, which again, maybe day one you don't, your databases are going to eat up all your RAM anyway. So you've got to set these. You've got to have limits and reservations. You're going to start out with them being very large, and you don't want to accidentally limit it too much or give it too much. So you make your limits high and your reservations low, so that you at least know what you're doing. And then over time, you're going to tighten those up, so that you have a more, as you watch them in production behave this way, you'll tighten those up. So you'll want those just on everything, really, if you can get away with it. Everything, at least the limits, maybe not the reservations, unless you are really concerned about that. You forgot about the sound effects, didn't you? So we're moving to the next one. This is going to be the tag team DevOps. So maybe you have a 2-member team, which doubles your operation capacity, and you maybe need to do a little bit more advanced stuff. So maybe you're moving to Terraform, and you're actually going to not use Docker Machine, because Docker Machine isn't really designed for 2 people. You have to come up with some solution to synchronize the certificates and stuff like that. So you're going to move to Terraform. Docker doesn't yet have a Terraform for CE that you can use, and I didn't do one before this talk, so my answer is there's a couple on Google that I saw that looked fine. Like, it's super basic, there's very small files, and it either works or it doesn't. So that might be a way you deploy your infrastructure.
Program loaded and ready.
You can also use these. AWS, Azure, Docker for AWS and Azure. If you're someone who likes CloudFormation, that's the way you want to do things. You can look at these templates. It does provide more out of the box than CE does. It actually has a couple of things built in, like a cloud store driver that you wouldn't maybe use Rexray. So I would take those templates and make them your own. Don't necessarily just use them raw from Apple. I almost said Apple. From Docker. And if you didn't know, in the brand new release that just came out, it's one of my favorite new features, other than BuildKit, is that you can now connect remotely to any Docker server without TLS setup, which is awesome. And it seems, they actually PR'd this a couple years ago, and it never actually got into the Moby until recently. So I'm super grateful that this is here now, because all you have to do is set an environment variable, and as long as you have SSH access to that server, you set that, and then your local Docker CLI acts like the server CLI. It's essentially tunneling SSH and running all the Docker commands. Even your builds and everything can run on that remote server without needing to expose the TCP port for the engine and set up TLS, which a lot of people do, and some people on the internet actually do scans and find out that we have a bunch of Docker servers on the internet that aren't secured. And what that is the TCP port that people have put on the opened it up, which isn't open by default, and exposed it so they can do remote stuff like this, but there's no security on it by default unless you set up TLS. So this gets you out of that whole thing. And in fact, now my approach to this is I do not open up the TCP port at all for administration purposes. Like, this is now my new policy. If you're an admin and you need to get on the server specifically for Docker things, obviously if you have SSH, you can do anything you want on the server from SSH. But I don't like people git cloning YAML files and stack files on the servers. I don't want them to do anything on the server. I'd rather them sit remotely and do Docker commands from their machine. So that's how you do that.
You watch your language.
Windows Server, I've just added that one today, so I forgot it was there. Server 2019, is anyone Windows people? I get more and more every time I talk to people. It's like it's continuing, the creeping in of all of us Windows people. So I've been Windows forever, so 2019 is better than the one before. This is now the 4th release, I think, technically, that has supported containers. We had, 2016, and then there was a couple of semi-annual builds, and each one got better with Swarm. And I think finally we're now, with 1809, at feature parity, where everything works with routing mesh and overlay and all the stuff between Windows and Linux. So we always had Swarm, always worked in some capacity ever since 2016, but there was always little gotcha edge cases. So those edge cases are almost completely gone now. I just don't have any off the top of my head that I know of, but I'm sure there's probably something. But it's great. So you can just add these nodes in, and away you go. You can leave your managers as Linux if you want, and just add in your Windows workloads, just like they did in the demo today.
Fascinating.
All right. You saw this today in the keynote. They didn't actually get it to work, but they didn't actually they didn't do a deploy. I think they were doing an install. Anyway, this is really cool, and it's hard to quantify what Docker app is because it does multiple things. But in this case, what I'm doing is I'm taking the YAML and I'm operationalizing it by giving it tagged versions and then shipping it to a registry, which means it's read-only now, right? So I can guarantee the versions of my apps via the YAML, not just the code. So now I can hard code application versions and then ship this YAML file to Docker Hub. It works today. And then if I need to deploy the app, I might choose to do this in a multi-member team because that way we don't have to constantly sync Git repos between each other just to ship off YAML to Docker stacks. So this saves me from having to do that. Obviously you're going to still want your infrastructure as code with your YAML and a Git repo, but these commands here would be the way I'm going to, if I'm in a team, I'm going to start looking at a workflow that we get to this instead of, and this tool may go away. We don't know that they're experimenting with it. It may actually be eventually put into Docker CLI directly. They're just keeping it separate for now to allow them to iterate quickly and experiment. It does lots of other things. It does templating of environment variables and whatnot, but I just wanted to tell you that because that is going, if you're in a team, that's going to help solve your stack deployment problem so you're not constantly having to git pull before you do things. So for security, I'm going to give you a couple of quick tools. Docker Bench, you would run once on your servers to make sure they were configured correctly when you deployed it. Aqua Microscanner, you would actually put in your Docker files to scan your images. These are all free open source. You scan your images. Sysdig Falco is a really cool thing. I actually want to give a demo of it today, but I'm just not going to have time. But I do mention it and link to it in the slides. And what that does is looks for bad behavior on your infrastructure and then logs it. So if someone execs into a container with a shell, it detects that and it detects anomalies of things like someone bind mounts proc, does other weird things that shouldn't be happening. You can make your own custom rules with it. It's now a CNCF project, so that's pretty great. And then user namespaces. And if you're not aware, that is a feature that comes out of the box turned off in Docker that I tend to enable. Not on all servers because it's a server-wide setting, but I enable it by default for servers and we try to get everything running that way. It essentially means your containers are no longer running as root. And it's fantastic. It was written by Phil, one of the captains who's here this week. And I love to enable it, but you got to be careful because not everything works in it. Sometimes things do really need root, especially when you're bind mounting. So if it doesn't work, then I end up leaving other nodes available that are sort of lesser security with it turned off. So you have to enable it in the engine for it to work. So check that out. Now you're going to get to the bigger servers and the bigger teams. So you're going to have at least 3 to 5 DevOps at this point, right? And full time, at least mostly full time. And maybe you're going to Amazon. Maybe you're getting big infrastructure. But the rules don't really change here. The tools might change, but the processes don't necessarily change. I'm bolding the words that are when I get to clients that are this big, they really don't change their approach. They're just like, we maybe need HA in our apps now. Every single one of our apps has to be highly available, not just our infrastructure. And we need failover at all levels and stuff like that. So again, we're still dealing with this. Maybe they choose to go Enterprise Edition on top of that. Maybe they still stay with the free stuff. But you can't use these templates. Damn it. So you can't use those. They're for CE only. They took that away this year. I think early this year. They took it away from EE and they're now moving to a new tool called DCI, which was released and then retracted a little bit. So if you have sales and support from Docker, look at DCI. It's basically Ansible and Terraform stuff that they're building out for you to automate your infrastructure deployments, but they're only giving it to enterprise customers and they're kind of in that iteration phase where they're not making it widely available, but I think next year we'll all be able to just use it for however we want, right? So, in fact, if you look at that infrastructure, it doesn't change much from what we just looked at. It looks a lot more complicated, but it's not. It's the same tiered structure that I handcrafted with my little crayons. I got workers in the back, I got managers up front maybe, and then I've got ELBs up top, and away we go, right? So these blue buttons are the things that changed. So if you get to the Enterprise Edition, you swap out parts of your stack for other tools that do the same thing, but the layers don't change. We still need a GUI. We still want monitoring and logging. We still need a registry and a layer 7 proxy. They're just different tools that do the same job. So in summary, basically infrastructure as code, everything as you possibly can, even if it's a shell script. If I can reproduce it, it may not technically be infrastructure as code, but if I can use a reproducible script when I'm a single person versus implementing a whole nother tool, I will probably prefer that if I'm a single engineer. If I'm a team, I'm going to work more on my infrastructure as code stuff. Don't make special nodes. Don't use one node as the jump host because it's a unique thing like a snowflake. Really, Swarm is designed for throwaway infrastructure. My favorite response to people that say, my node is acting up, I don't know what's wrong with it, and my response is, well, throw it away and build a new one. Like, you spent 2 hours on it, and there's nothing special on it. Maybe there's a database running, but hopefully if you're to that level, you've got some sort of high availability in your databases, so it will just recreate that. I think my example was for the single person DevOps, your requirement is just that things spin back up within maybe 10 seconds, and there's not true high availability on every app, that you just have an orchestrator that's automatically going to fix things that fail. Sometimes that's good enough. That's still 4 nines or something. So you maybe don't need all that. And grow as you go, like I say, keep it simple at first, grow as you go there. And when you're looking for solutions, a lot of people ask me, how do I do, since I don't have Helm, how do I do X, XYZ? And I say, go look for the compose files. Like the compose files are going to teach you the patterns. You just maybe add some environment variables and labels and things like that. If you're into databases, look for the keyword autopilot pattern, which is by Joyent. They sort of created this initially. It's called the autopilot pattern, and it's their idea around how do I get database, like even legacy database systems, to auto form their whether it's a replica set or a database mirror or whatever. So if you just kind of Google MySQL or Postgres or whatever, MongoDB, and then the word autopilot, you will probably find a compose template that you can use in Swarm in production that will auto-create a cluster without you, a database cluster, without you having to manually do anything. Without you having to, you don't obviously want to go in and manually create clusters in SQL. And then don't throw out the good in the search of the perfect. I think a lot of times on the internet we love, and at conference we'd love to show the amazing perfect thing. And I really like something that is at least reproducible but not perfect, rather than someone trying to implement a whole nother tool just because it's the cool new thing. Where do you go from here? After this talk, there are a couple of options. You got automating Docker Enterprise. If you're interested at all in Enterprise, you can check that out. I got some friends in there. And then the really cool one is from one of the award winners today, Citizen Bank, I believe. They're doing mission critical migration to multi. So basically what that is, that's Swarm to Kubernetes. So what they did was they have a lot of stuff in Swarm, and a couple of things specifically, they like cron stuff and jobs that they wanted to do it in Kubernetes. They moved those over to that orchestrator and left the rest in Swarm, and they talk about exactly how they did that and how they migrated. I'm doing a Swarm workshop today and tomorrow, so if you're new to Swarm, this talk was probably a little fast for you, but I have a workshop that's an intro. We go through a whole lot of the stuff that we did today here. You're going to build your own 3-node Swarm on AWS with your own infrastructure, and I do it again tomorrow at 1:30, and then I'm also doing a hallway track tomorrow so that people can just sort of commiserate about the burdens of operations and how we all, wish it would go away and we could do something else.
Live long and prosperous.
So I want to thank you for coming. This is basically the end of the talk, and I want to make sure that you know that, again, if you're using open source, it is not free. Someone's spending their hard-earned time on it. So if you have any way to give back to any tool you do, please do that, whether it's time, money, or just advocating for it, like I do for Traefik. And thanks for coming. Again, there's the slides up there. You can get the links for all the slides.
Great. Thanks, Bret. If you want to take, we have 1 minute for questions.
Yeah, let's do it.
Any very quick questions?
I'll be outside for a while in case we have questions.
Bret, about Traefik, Nginx does the same thing, right? What is the difference between the Nginx and Traefik?
Well, there's a whole lot of differences. One is that Nginx can also be a web server. Traefik cannot. Nginx can cache files if you want to make a reverse proxy with caching, and Nginx and Traefik I don't think can do that yet. But the nice thing I like about Traefik is that it's a very specific tool. It's very small. It's a Go single library, I believe, and so it's very single binary rather. And so it's very tight and focused on what it's trying to do instead of sort of being a jack of all trades tool. My favorite thing about it though is that Let's Encrypt is built in. So if you want to use Let's Encrypt at all, it doesn't even require the switches on it basically is just you add a couple of options at the end of the command in the compose file, and then it went out for all of my demos and got me official real certificates for my domains for each new app I deploy. It goes and gets that certificate automatically, so I don't even have to bother anyone for certificates that work in browsers. So that's honestly my favorite feature of it, but it's really just focused on proxy.
Thanks.
Yeah.
Great. Thanks, Bret. And as Bret said, you can catch him outside. Thanks again.
Hey.